So let's discuss sexual differentiation in pathology. First of all, when we are developing, we have basically neutral primitive gonads. That means it has potential to become either a testes or an ovary, but has not done so yet. And you have two ducts. You have the Mullerian duct in pink, and this can develop into the female internal structures, that is the upper vagina, uterus, and fallopian tubes. And you have the Wolffian ducts, and these have potential to develop into male internal structures, which referring to the epididymis, the vas deferens, seminal vesicle, and ejaculatory duct. Now, the question is, how does this happen? How does this decide whether to become an ovary or a testes? And I, being a male, only have this male structures. Why don't I have both of these structures, since I started out with the Mullerian duct as well as the Wolffian duct? So what happens is that the default pathway here is the pathway of the female. That means that the Wolffian duct will disappear, slowly disappear, and then this primitive gonad is going to turn into an ovary, and this Mullerian duct, aka the paramesonephric duct, will develop into the female internal structures. Again, what are those? That's the upper vagina, that's the uterus, and the fallopian tubes. And then the ovary will then secrete estrogen, and estrogen will nourish the external female genitalia. It's going to turn the genital tubercle into the external female genitalia. That is the lower tract of the vagina. That's the vulva. The vulva, again, containing the labia majora, labia minora, and all those other things. So I'm a male. I still have no idea how do I get my male structures. How did I get my testes and all those things. And the magic lies in the chromosomes. So if we look at chromosome 23, we have either the Y chromosome, or this is the X chromosome, sorry. The Y chromosome is kind of small. And on the Y chromosome, there's something called the SRY gene. And what the SRY gene does is it encodes the production of something called testes differentiating factor. That's testes differentiating factor. And when you have this factor, it is going to stimulate development of the testes. So this, I'm going to look at this side now, becomes the testes. And do you remember what two cells are in the testes? Two cells are the Leydig cells and the Sertoli cells. First, let's look at Sertoli cells. Sertoli cells secrete something called Mullerian inhibiting factor. Obviously, what does the name tell us? It inhibits the Mullerian duct. So this pink stuff goes bye-bye. So that means no more female internal structures. Which is why because I have my SRY gene, because I have the Y chromosome, I make testes determining factor. And that is going to cause development of my testes, and my Sertoli cell is going to make the Mullerian inhibiting factor, and it's going to promote degradation of the Mullerian ducts. Now, Leydig cells, do you remember what Leydig cells make? Leydig cells make testosterone. Testosterone is going to act on the Wolffian duct. It's going to stimulate production, development of the male internal genitalia. That would be, again, the epididymis, the vas deferens, the ejaculatory duct. The other thing that will happen, is that the testes the testosterone is going to be turned into dihydrotestosterone. That's DHT. And the enzyme that stimulates this conversion is called 5-alpha reductase. This is important because DHT is going to take your genital tubercle and it's going to cause development of the external male genitalia. Okay, so remember again that external genitalia both come from the genital tubercle, and you have a lot of analogs, but the estrogen will cause for females the genital tubercle to develop into the external female genitalia. That's here, and then DHT is what's going to cause your genital tubercle to develop into external male genitalia. So the sequence of events is super important, and we're going to talk about some pathology that when this sequence of events goes wrong.